Hey guys, welcome to Algebra 1. Today's lesson is going to focus on negative exponents. Now all that you know about the laws of exponents and quotients and products is going to help you get through this lesson. Ready to get started? Let's go. Okay, so I want you to think about this problem in two separate parts, okay? First thing I'm going to do for the right side of it is I'm going to expand it out. So I know that x cubed divided by x to the fifth. I know for my numerator, that means that I have x times x times x, right? If I'm raising x to the third power, I'm just multiplying by 3x's. And for the denominator, if I have x to the fifth, then that means x times x times x times x times x. Let's make that fraction bar a little longer. Okay, so for the denominator, if I have x to the fifth power, then that means I'm multiplying 5 x's together, okay? Now, knowing what you do about simplifying fractions, you know that you can always cancel out the same thing. If you have the same thing in the numerator and the denominator, then you can start canceling things out, right? So I know I can cancel out 1x up top with 1x in the bottom. I can cancel out another one up top with another one in the bottom. I can cancel out another one up top with another one at the bottom. Now is where we have to kind of throw in a little trick. We don't have 0 up top. It's not a value of 0. But you know how there's always that invisible factor of 1 hanging around? So I'm going to throw up here that this is like x times x times x times 1. I'm just going to throw that out there. So I've canceled out these 3x's up top with these 3x's on the bottom. And what I'm left with is a 1 up top, and I'm left with x times x on the bottom, right? Now, I could represent that differently. I could say, okay, well, 1 over x times x, that's really the same thing as 1 over x squared, right? Okay, so that's what the right side of that looks like. I'm going to box that in so we can kind of focus on that for the right. Now let's go back to the left side, how this problem started. We had x cubed divided by x to the fifth. Now you know that one of the laws of exponents tells us that when we have this type of setup, when we're dividing powers, we can subtract the exponents. So I could represent this as x to the 3 minus 5, because I need to subtract those exponents to simplify them, right? And then what is 3 minus 5? Okay, let's come off to the side and do that. 3 minus 5, that's negative 2. Knowing what you do about integer operations, or just put that in the calculator if you want, whichever one you want to do. Okay, so I know that x to the 3 minus 5, that's the same thing as x to the negative 2. So what that means is x to the negative second power is really the same thing as 1 over x to the second power. Okay? Sounds a little crazy at first, I know. Let's do a couple more to make it make sense. Okay, so let's take this one. I'm going to apply that same process, right? Okay, so x to the fourth, I know that that's the product of 4 x's. So x times x times x times x, okay? And then on my denominator, x to the seventh, that's the product of 7 x's. So x times x times x times x times x times x times x. Let's count that to be sure. 1, 2, 3, 4, 5, 6, 7. Yes. All right, I'm going to expand that or draw that fraction line a little longer. Now, you remember on the last one when I threw in that factor of 1? Because multiplying by 1 doesn't change anything. I'm going to do that right now to start. So x times x times x times x, I'm going to multiply times 1. I'm going to throw that in there. Okay, didn't change the problem at all. All right, now let's start canceling things out. So I can cancel out 1x in the numerator with 1 in the denominator. I'll cross them out like that this time. I can cancel out another x in the numerator with another 1 in the denominator. Another 1 in the numerator with another in the denominator. And another 1 in the numerator with another 1 in the denominator. And what I'm left with is a 1 in the numerator and then the product of 3 x's in my denominator. All righty? So I'm left with 1 over x times x times x. I'm going to represent that differently. And I'm going to say, well, this is the same thing as 1 over x to the third power, right? So we expanded it out, and we looked at what it looked like that way. Now let's go back and look at how this problem started. This x to the fourth over x to the seventh, okay? So knowing what you do about the laws of exponents, you know when you have to find the quotient of powers, you subtract your exponents. So let's do that. I have x to the fourth divided by x to the seventh. So that's x to the 4 minus 7, right? So 4 minus 7, come off to the side. That's negative 3, okay? So I could represent that as x to the negative 3. So x to the negative third power means the same thing as 1 over x to the positive third power. Are you starting to notice the pattern yet? Let's try another one. All right, x cubed over x to the 8th. So I know I can represent x cubed as x times x times x. And I'm going to throw in that times 1 because it didn't change anything. And then I have the product of 8 x's on the bottom. So x times 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 x. Let's double check. 3, 4, 5, 6, 7, 8. Okay, we do have 8 x's up there. Okay, now start canceling things out. Let's start simplifying. I can cancel out 1x in the numerator with 1 in the denominator, another 1 in the numerator with another 1 in the denominator, and another in the numerator with another 1 in the denominator. And when you do that, you're left with that 1 in the numerator, and then you have 1, 2, 3, 4, 5 x's in your denominator. Okay? And then you can simplify that. You can write that a little differently. I can leave my 1 in the numerator. And since I'm multiplying x by itself 5 times in my denominator, then I can represent that as x to the 5th. Okay? So we handled the right side. Now let's handle the left side. All right, x to the 3rd divided by x to the 8th, applying that law of exponents, right? If you have to find the quotient of powers, you subtract your exponents. So I need to simplify that as x to the 3 minus 8. Okay. Then go ahead and clean that up. Come off to the side. What is 3 minus 8? Well, that's negative 5. Right? So that means that x to the 3 minus 8 simplifies to x to the negative 5th power. So x to the negative 5th means the same thing as 1 over x to the 5th. Did you pick up on that pattern? Each and every time, if you notice, when you raise a value to a negative power, it's the same thing as 1 over that value to the positive power. That's how you handle negative exponents. Okay, let's look at this rule. So any value raised to the negative power, any negative power, it means the same thing as 1 over raising that value to a positive power, except for one value, 0. Let's get a pen. So when you raise 0 to a negative power, this gets into some stuff that's a little heavier than Algebra 1, so you won't really see this too much in this course. So you can just focus on this rule, knowing that a will never be 0, okay? So any value except 0 raised to a negative power, it means the same thing as 1 over that value to a positive power, that same power but positive. All right, let's try a couple problems. All right. So we have 5x, and we're raising that to the negative 2nd power. So what I'm going to do first, since I know my rule, that anything raised to a negative power means the same as 1 over raising that same value to a positive power, I'm going to rewrite this as 1 over 5x to the positive 2nd power, because those values mean exactly the same thing. I'm just going to work with that positive exponent to help me make my problem more simple. Okay, so I'm going to keep simplifying this. And notice in my denominator, I have a product, and I'm raising it to a power. So I need to apply that rule of exponents. And I'll come up to the side and do a little work down here. I need to raise that 5 to the second power, and I need to raise that x to the second power. I guess we can actually put our work up here. We're going to raise our 5 to the second power, and we're going to raise that x to the second power. Okay, let's keep chugging along. 5 squared, I know that's 25. And x squared, it kind of took care of itself. You got x squared. And then once you're there, you're all done. You can't take it any further. So 5x raised to the negative second power means the same thing as 1 over 25x squared. Okay, let's apply this again. Give you a little practice here. All right, so we have x to the 5th, y to the 8th, over x squared, y to the 10th. All right, now this one was a little different than the other one, but remember, you don't want to memorize my steps. Memorize my process. That's what you want to learn. So here, I see I have a quotient, and I have a product up top, and I'm dividing it by a product at the bottom. And I notice I have some of the same bases here. I have an x and a y up top, x and a y on the bottom. So I'm going to take that as my cue to kind of group the like things together. Okay, so I'm going to handle the x's first. I need x to the 5th over x squared. And then I'm going to multiply that by y to the 8th over y to the 10th. So I just broke it up just to help me kind of deal with it a little easier. All right, so knowing what I do about the laws of exponents, I know when I have a quotient of powers, I need to subtract the exponents to make it simple. So for here, I have 5 and a 2. So I know 5 minus 2, I'll come off to the side for that, 5 minus 2, that's 3. So as far as my x's go, I have x to the 3rd power. And then for my y's, I have an 8 and a 10. I need to subtract those. So 8 minus 10, that's negative 2. So you see where our negative exponent popped up in this problem. So y to the negative 2nd power. Okay. And I'm going to keep going across with this one. X cubed, it's fine. I don't have a negative exponent. I really don't need to do anything with that. Actually, I'll come underneath. Now, I know what I do about the negative exponent. So for y to the negative 2nd power, I know that I can rewrite that as 1 over y to the positive 2nd power. And those values mean exactly the same thing. In algebra, you don't want to have negative exponents as your answer. You want to make sure that when you've taken it as far as you can go, your exponents are all positive. So that's why we couldn't leave it like that, and we had to keep going. Now, you could stop here, and you wouldn't be wrong necessarily, but more than likely, you're going to see your answer written like this. You're going to go ahead and multiply those two terms together. And you're going to see it written as x cubed over y squared. That's more than likely how you're going to see that answer written, which basically is that they multiplied our numerators together. X cubed times 1, that's just x cubed. And you remember fractions, you can always make something that's whole a fraction by putting it over 1. So 1 times y squared, that's y squared. That's how the problem went from this to this. But either one is really acceptable. Okay, let's keep going. All right, so we have c to the 8th, d to the negative 5th over 3, and we're raising that entire quotient to the 3rd power. All right, so we need to apply a couple of laws of exponents here. I'm going to start by breaking this up. I'm going to separate my numerator from my denominator. So I'm going to write this as c to the 8th, d to the negative 5th, and I'm raising that to the 3rd power, over 3 to the 3rd. Okay, so basically I just distributed that exponent throughout those pieces in my quotient. All right, so now that I see the numerator, it's a product, I need to keep on carrying that exponent throughout. So I need to raise c to the 8th to the 3rd power. So c to the 8th to the 3rd. And I need to raise d to the negative 5th to the 3rd power. So d to the negative 5th to the 3rd power. Okay. And then my denominator, I have 3 to the 3rd, and I can go ahead and take care of that. 3 to the 3rd, that's 27. Alrighty. So the denominator is pretty much done. We've got to clean up the numerator here. So you know about raising a power to a power, right? So in this case, you need to multiply your exponents together. So 8 times 3, that's 24. So that first part becomes c to the 24th. And negative 5 times 3, that's negative 15. So d to the negative 15th. And then we'd already taken care of that 27, right? Not quite done yet, because we see we have that negative exponent. So we've got to keep cleaning this up. Let me shift a little work around here, get some more space. Okay, so since we've already taken this problem from this step to this step, I'm going to get rid of this up top so we can focus on where we are right now. And I think I'll also get rid of that. All right, now, do want to see my work here. All right, let's bring this work up top. All right, and let's get rid of that slash through because we didn't want to slash through that. All righty, let's keep going. Get the pen back. Here we go. All right. So what we need to do is we need to handle that negative exponent, that negative 15. Now here's when you can kind of use a shortcut. You know the rule tells us, if I rewrite the rule, if we have x, say, to the negative a power, I'll change it up a little bit, that's the same as 1 over x to the positive a power. So as a shortcut, you can also think about this as, if your negative exponent starts out on top in a quotient like this, just drop it to the bottom and make it positive. If we had started with the negative exponent at the bottom, then we would need to bring it up to the top and make it positive. It's like you're shifting its position. You could think about that as a shortcut, okay? So what that means is I can rewrite this as c to the 24th. And because this part of this term here has a negative exponent, I'm going to bring it to the bottom. So I still have that 27, and I'm going to drop that d to the bottom and then change that exponent to a positive 15. You've applied that same rule for negative exponents. You kind of just took a shortcut to get there. All righty. Okay. That's kind of the trick with algebra. Once you pick up on patterns, algebra is really just a bunch of shortcuts that people figured out over time by just noticing a bunch of patterns. Okay, so use your knowledge of patterns to really help you get through the course. All right, looks like it is your turn to try. So look at these 3 problems. Go ahead, pause the tape, take a few minutes, and work your way through them. And when you're ready to compare answers with me, go ahead and press play. All right, you ready to get going? Let's compare our answers. Okay, so for the first problem, you had 6y and you were raising it to the negative 2nd power. You should have got 1 over 36y squared for that one. All right, number 2, you had a to the 7th, b to the 6th over a to the 11th, b. That one simplified to b to the 5th, a to the 4th, over a to the 4th. All right, and for number 3, you had s to the negative 3rd, t to the 4th over 9, and you were squaring that quotient. That answer was t to the 8th, 81, s to the 6th. All right, now if you want to see how I did any of these, then stay with me. All right, let's take a look at that first one. So I have 6y, and I'm raising that product to the negative 2nd power. So I'm going to apply my rule about negative exponents, which tells me that I can represent this as 1 over 6y to the positive 2nd power, right? Now I just need to simplify this denominator. I've got my 1 up top, and that's all good to go. I need to raise each of these individual pieces of this product to the 2nd power. So I have 6 to the second power times y to the second power, right? And then just simplify this a little further. The 1's good to go up top. 6 squared, I know that's 36. And that y to the second power took care of itself. It's already simple. So that's how I got that first answer, that 1 over 36y squared. Okay? Need to see the second one. Here we go. All right, so I had a to the 7th, b to the 6th, over a to the 11th, b. So what I did first is I broke this up. I grouped kind of the like things together. So I looked at it as a to the 7th over a to the 11th, and I was multiplying that by b to the 6th over b. And then I used what I knew about the laws of exponents to know that if I have a quotient of powers, that I need to subtract the exponents. So for the a's, you have 7 and 11. Come off to the side here. 7 minus 11, that's negative 4. So I knew that the first part of that was a to the negative 4th. Now for the b's, I had b to the 6th, and then I had b. And remember, when you don't see an exponent, there's an invisible exponent of 1, okay? So always remember, if you don't see an exponent, there's a 1 there that you're really not seeing. Just write it in. Okay, so for this one, b to the 6th over b to the 1st, basically. Subtract your exponents here. So 6 minus 1, that's 5. So I knew that this was times b to the 5th. And I knew I wasn't done yet because I had a negative exponent. So you remember, we use what you know about patterns, and we just take a shortcut here. That a to the 4th, that's part of the numerator right now. So I need to drop it to the bottom, make it positive. Okay? And that is how I got that second answer. All right. If you need to see the third one, here we go. So we had s to the negative 3rd, t to the 4th over 9, and we were squaring that whole quotient. So I started out by breaking it up. I took my numerator, s to the negative 3, t to the 4th squared over 9 squared. Okay? And then I used what I knew about exponents to apply the rule of raising a product to a power. So I needed to raise s to the negative 3rd power to the second power. I needed to take these pieces separately. Now I need to raise t to the 4th to the second power. So t to the 4th to the second power. All right. So I'd handle the numerator. Now for the denominator, 9 squared. Okay, that's 9 times 9. So that's 81. So my denominator is kind of all taken care of. But I'm not done yet. I've got to handle that numerator. All righty. So raising a power to a power. Negative 3 times 2, that's negative 6. So s to the negative 6. 4 times 2 here, that's 8. So t to the 8th. And then that was all over 81. But you see you have a negative exponent, so you're not done yet. I think I actually may be able to fit that over here. So we use what we know about negative exponents, and we can take that shortcut. I know that t to the 8th isn't going to go anywhere. It's fine. But that s to the negative 6, I've got to take care of that. So you apply the rule about negative exponents. The 81's good to go. I'm going to drop that s to the bottom and make that exponent positive. Because remember, the rule tells us if I'm raising something to a negative power, it means the same thing as 1 over that to a positive power. So you can follow that pattern and know you need to change its position in the fraction. All right. And we were all done there. Okay, guys. I hope you're feeling more comfortable with negative exponents. And I hope that you saw how products and quotients and factors, all that knowledge really helped you get through these type of problems. Hope to see you back here soon. Bye.